Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. We have been working on this beautiful Bally Medusa pinball machine, one of their most complex early solid-state games, and we are up to the part of the repair where we need to work on the soundboard. The thing is completely silent because the soundboard doesn't work. So this is going to be a very special video. What I'm planning on doing in this video, if I can pull it off, I'm going to try to fix the original board, and then I'm going to install a reproduction or a new edition of the board that has added features and things like that. So that's what we're going to attempt to do in this video. So let me show you the original board first, and then I'm going to show you what we're going to replace it with, okay? And I'm going to tell you where you can get it if you feel like it. This is Bally's SQUAWK and Talk board, and yes, it is actually called that. That's what it says on the side of it there. Bally had all kinds of interesting names for all of their different variations of soundboards. They had the Sounds Good board and all kinds of stuff like that. But this is the SQUAWK and Talk. This is a kind of famous board, although it was only used on a few pinball machines. It was used on several of the Ballys that talk, so people kind of have a soft spot for it. This one does not work. Now, the reason it's not working right now is because the ROMs have been removed. So we've been working through this machine. It was in kind of rough shape whenever we got it. The ROMs are up here. And Joe was messing around with it. Whenever he got to the board, he noticed that there was something going on with the ROMs, so he pulled them out, and they weren't right, and so here we are. So that's going to be part of it. But on these original boards, they actually have a flash code with that LED there that tells you sometimes what's wrong with it, okay? So we're going to fix that board just to see if we can get it up and running with that, and hopefully we can maybe compare that to the new board. So let me show you the new board and the new option that we've got, just so you can see the new cool tech that's out there. Okay, so look at this beautiful board here. Now this is one of the early versions of it. From, as I understand, talking to this gentleman, he has a new updated version that's made a little differently, but it's basically the same concept. Now you can see this one is from January of 2022. We were filming this in September of 2022. So he has a newer revision, but this is basically what it's going to look similar to this. And this says version 6. Now here's the gentleman's website, geeteoh.com. I see that as Gito, but I don't know. I've never heard him pronounce it, so if I got that wrong, it is what it is. But he doesn't just sell soundboards for this system or this game. He's got a whole bunch of different ones. So if you've got a sound problem with one of your machines, you might consider checking out his website. He makes nice quality products. But then also, if you've got one that hasn't been made yet, like some of the Data East stuff, he may be interested in making them if you start up a conversation with him. He's kind of into this right now and is making a lot of different soundboards. Phone's ringing, people. I'm not going to answer it. They'll be all right. You think they'll call back? So it's got 3 relay. They called back. It's got 3 relays on here. It's got several dip switches. Okay. It's got a little meter here, or a little LED display. I am not technical enough to know what some of these chips are, but it has a volume adjustment for background, for sounds, and for voice. Oh my Lord. They got to talk to me, people. It's very important. Let me go see what's so important. They wanted to know if we had any Madden games. Yeah, we got Madden games. Okay, so this is the board. It looks pretty cool. Like I said, I don't really completely understand all of this stuff, but luckily it has a manual with it. Okay. And then it has a little memory card, I assume, is what helps it know that it is a Medusa. Okay. And then over here, I would imagine that might be like a, well, I don't know. I don't want to guess. Oh, amp volume. Okay, so that's your main volume. Okay, so they have a different knob for the background music, the sound effects, and the voice. Pretty cool. Okay, so here is the manual for it. SQUAWK and Talk replacement soundboard. Basic installation instructions, and it's a nice thick manual. Sound types. Each sound is assigned a sound type depending on the game title. This is one of the reasons why you must select the game title with dip switches. Okay, it's because there are different sounds depending on what game it's in, right? That makes sense. So it's a nice thorough manual. But first we're going to try to fix the original one. Then if we can get the original one playing, we will play the new one and see if it sounds similar or how close he got it to the original, and then what extra he's got on the new boards. That's what we're going to do. So the way you would typically fix this is when you turn it on, that light will flash several times, telling you different problems that the game has. So it may flash 4 times, and that means that whatever that means in the manual, it will explain that to you. Sometimes if you hit this reset button, it'll do it. But I think since we've removed the sound ROMs, we're going to have trouble with that. So let's check those out and see if I need to reburn new ones or what the deal is. It could just be as simple as the sound ROMs are messed up. Okay, so looking at our first chip, which is U3, it has legs broken off of it. Joey noticed that, and that's why he pulled it out of the board. So one there, several here, and they're just all corroded and nasty. Okay, so I have made a brand new one. It's 2532, and there it is. Now you may say, where do you get the files from? Well, you can get the files from PinMAME. That's the whole purpose of MAME. The Multiple Arcade Machine Emulator is to preserve the software, basically, and the hardware, but mainly the software. So there are copies of the ROMs of all of these that will work in PinMAME. But on the Bally stuff, Bally has been kind enough to actually, the company Williams owns all of the Bally stuff. Williams and Bally merged. Williams has actually been kind enough to release all of the software to the public to help maintain the old machines. So you can actually still get all of the Bally software out there. A lot of it you can get from ipdb.org, the Internet Pinball Database. You just type in a machine name, and on a lot of the machines they will have a copy of the ROMs. So we have a copy from the IPDB, the Internet Pinball Database, and so I'm able to burn new ROMs, thankfully. So we've got this one. I'm going to pop it in U3, and then we'll look at U4 and U5. Okay, so here is U4. It's deceptively good, but one of the legs is pretty weak. So sometimes they'll look fine, but when you start messing with it, that leg, I just barely touched that. That thing is about to break. So it's going to join its brother there, too. Now I know you can repair just the leg if you want, but things are getting old. So I'm going to put this other old one in there. These haven't seen the greatest of times. This one here, though, it's still all right. Okay, so this is U4. It checks out. On to U5. Now, U5 is a 2716, so it's a smaller chip. All right, we got them back in there, people. The U5 actually tested. It was still fine. Okay, so we're going to try it out. Now, there is an LED here, like I said, that does a flash. Let me show you the one up here first. So, well, it might start. Let's see if she starts. But watch the LED and see if it blinks and tells us anything. 1, 2, 3, 4. It seemed to have flashed 4 times to me. Okay, now watch the MPU. It does the same thing. The MPU flash code is world famous. So it does like a real quick flicker and then 7 flashes. 1, 2, 3, 4, 5, 6, 7. The quick flicker was a full-on flash. So it did on the original board. It does a quick flicker and then 7 flashes, but the flicker's kind of a flash. Okay, so this one's doing the same thing. It's supposed to do a quick flicker, and it is an original board, and then 5 flashes after that. So let's see. One, 2, 3, 4. Okay, so that clear as day was 4 flashes. I don't even think it's arguable that that was 4 I didn't see a quick flicker though, so let's go look at the manual and we will see what it's supposed to be doing and what 4 flashes means. Alright, so this is one of Bally's super duper repair manuals. They would do these long manuals that, there's a manual for each game, but then there would be a long manual that helps you kind of troubleshoot it. So let me show you what the title of it is. We're on page 83. We got to go back. Here we go. We're going up. Alright. These are floating around all over the place. They came with the game, usually. If it was a game that used this particular repair procedure manual, it came with it. So a lot of games had these. There's millions of copies of them floating around. You can buy them on eBay and stuff if you don't have it. But there's different revisions. So this FO560-3 is the version that just happens to have the information for the Squawk and Talk. There was a -1 or whatever before it that went with the early games, and then they updated it as time went on because they had new boards and things. Yeah, here we go. So it's going to tell you right there. So they did one in 76, and then a sequel in 76, and then they did another one in 77, and one in 78, one in 80, and this is the one from 81. Looks like it's actually the 4th revision. Okay, so where were we? Page 83. Is that what it was? I believe that's what it was. That's what it was. What it is, nephew. Okay, so the official part number for the Squawk and Talk is AS-2518-61. I believe AS-2518-01 was the original MPU board. I believe. No, it's -13, I think. Doesn't matter. Okay, so it explains the theory of operation, so this would be helpful to us. It says Squawk and Talk self-test. The Squawk and Talk module has, as part of the integrated circuit U5, a program designed to test the module each time power is turned on. Okay, so what are they saying there? ROM U5 has to be good for this program to run because the program is actually on U5. So that was the last one that we checked. That was the one that was the 2716. That's why it's a little smaller than the other chips. The other ones contain game code, but ROM U5 contains the self-test and like the boot up information and all of that. But the specific sounds and things like that for the game are on the other 2 ROMs. Okay, every time power is turned on, no action is required on the operator's part to initiate the test. The program causes the... I can't pronounce that because people tell me that I'm not pronouncing it right. That's not a U, people. I've been told that's not a U. So here we are. We can't pronounce it because I'm not allowed to call it a U. The program causes the mu. I think that's the technical way to say it. I'm holding my hand like this when I do it. The mu. The UP chip to test itself, U1. The scratch pad memory, U6. Each of the in-out chips, which are peripheral interface adapters, U7 and U11. The sound generator chip, U12, and the speech generator chip, U8. Oh, really? If the MUP chip finds all circuits in proper operating order, it initializes the Squawk and Talk module and makes it ready for sound effects. If the UP finds a fault, I believe that's supposed to mean micro. If the microprocessor finds a fault during the course of self-test, it stops at that point in the test and does not allow gameplay. Now, it does allow gameplay, it just doesn't allow sound play because this is just the sound test, the soundboard. Okay? The accuracy of the Squawk and Talk self-test is about 90%. That's mighty brave of them to admit, don't you think? That's pretty cool. And can we give a hand to Bally for at least letting us read this crap? Most other companies, modern companies, they would never tell you about test modes and if the chip, how to test the chip and all that. So right on, Bally. Good job. We appreciate it. Hopefully we can use it to fix ours. The Squawk and Talk module catches all faults except digital to analog converters, voltage-controlled amplifiers, power amplifier, speech from, and input interface problems. The interesting idea, now this is the engineers themselves are writing this, you know. Let me tell you about the interesting idea behind the SQUAWK and TOF self-test. It's that it not only prevents sound generation when faults are detected, but like the MPU module, it helps to localize these faults. The LED on the SQUAWK and TOF module flashes once for each successfully completed test. Simply counting the number of flashes of the LED after power-up localizes the fault to the offending circuit of the module. But see, here's the problem. I can't tell if that's a flicker. Can't tell. All I can tell you is there was a big long pause after the first one, so that might help us figure it out. Okay? First flicker. On power-up, the microprocessor chip U1 requires that the 5-volt plus or minus a quarter volt DC be applied before the reset line is allowed to swing from 0 to 4.8. If these conditions are met, and if the microprocessor chip is good, the LED on the module flickers briefly for approximately 300 milliseconds. Did you see a third of a second flash? I don't know, people. This flicker, I don't think we're seeing. But it's happening because all it does is test the reset, right? So it just ain't flickering, but it's probably so quick my eye can't see it. That could be what's going on. The reset circuit on the SQUAWK and TOF module works with the 5-volt DC regulator VR1 to prevent the reset line from going high until the 5-volt supply has had time to stabilize after power on. At power on, C1 slowly charges via R1. The voltage across C1 is monitored by U15. When it reaches 1.7 volts DC, U15 takes the reset line high. Wham! Whoop, there it went. U15 is a Schmidt trigger device with a built-in hysteresis. They shouldn't have called it. Come on. You're not supposed to use that word. That's an old-timey. You're not supposed to say that. It ain't right. Some of y'all know what I'm talking about. To prevent slowly changing inputs from causing multiple outputs. Okay. Diode CR1 across R1 provides a quick discharge path for C1 in the event that the 5-volt momentarily disappears. If the LED stays on, the probable causes are a faulty U5, that's the ROM chip, a faulty U15, I don't know what that is, a leaky C1, an open R1, a leaky CR1, or a faulty U17. Okay, but I think that's happening because that thing's not going to keep flashing if we don't get the reset, because the microprocessor wouldn't even run, right? Okay, so first flash, the microprocessor chip U1 next goes out to the NMOS RAM. It attempts to write, then read back all 256 patterns in each of the 128 scratch pad RAM locations. If at any point in this test the microprocessor fails to correctly read back a pattern that it has written, U6 is deemed defective and the microprocessor will not allow sounds to be made. If the microprocessor completes the 256 times 128, that's 32,768 tests successfully, it flashes the LED. Now remember what I just said? I've said a lot, so you probably don't. It waits a while after that first flash. You know why it's waiting a while? It's because that is the first flicker we're seeing. It's trying 32,768 tests, and then it makes what it's calling the first flash. So that first flash we're seeing is actually this flicker, I think. And then it goes off, and it stays off because it's running all these tests, and then it flashes and it does the other ones quick. That's my theory. Okay. Okay, the microprocessor chip, U1, now tests the first peripheral interface adapter chip, U7. Each of the two PIA chips, U7 and U11, are identical and interchangeable. They're 6821s probably. The test for both is identical. To determine if each of the two peripheral interface adapter chips are good, the microprocessor chip does the following. Now this page here is out of order in this scan, so it's right here. It tests each of the two full byte port initialization registers in a manner similar to that of U6. It tests each of the two full byte in-out registers, PA0 through 7, PB0 through 7, in a similar manner to U6. It then tests the CA2 and CB2 ports. The ports are initialized as outputs. The port is then written into to see if it can store a 1 and then a 0. When both ports are found good, the microprocessor flashes the LED. So that's the second flash. Okay. The third flash is the microprocessor performs the same tests for U11 as it did for U7. It then flashes the LED. So think about it like this. If that first, so we're seeing one flash and then it goes off and it waits a little bit and then it does some quick flashes. Okay. So I was saying, I thought that first flash might be the flicker. It can't be the flicker, because if it was the flicker, after that's done, it does the next test real quick. Right? So that's got to be, that first flash that we're seeing must be, well, I'm all discombobulated already. So there's a lot of math between the first and the second flash. So that first flash we're seeing, no, I got that wrong. There's a lot of math between the flicker and the first flash. So anytime, if there's a time period where it has to wait a while, it's because it's doing all of these tests. Okay? So since we're seeing a flash and then it waits a while and then it's real quick, it's because it's finishing all of the RAM and then doing the PIA and then doing the other PIA. If the first flicker was what it was waiting, or if we don't see the flicker and then this is the first flash, it would never wait a while before it did the second one and then immediately test the third one so quick that it doesn't even have to wait. Because you saw how quick it goes from the second to third flash. I know all this is confusing, but we're going to get to it. We're going to figure it out, people. Don't worry about it. Okay, the fourth flash. The microprocessor chip U1 performs a test similar to the test for U6. Okay, so U6 is the first PIA. Also, oh yeah, U6 is the last. No, I got this all screwed up. The microprocessor chip performs a test similar to the test for U6 on the sound generator chip, U12. U12 is controlled through PIA U11. If the sound chip passes all tests, then the microprocessor flashes the LED. Okay, which one was U6? It doesn't help that we got a page out of order here. Okay, U6 is the RAM, so that would again take a bunch of time. So it seems to me like there would be a wait before the first flash, because that tests the RAM, and then the next two flashes would come pretty quick because it's just testing the PIA, and then there would be another wait before the third flash because it has to do a whole bunch of calculations again. Okay? And then that's the fourth flash, I'm sorry. The fifth flash, the speech generator chip U8 requires an initialization sequence on power up. Since the speech chip is a slow device, there is an acknowledgement signal from the speech chip to the microprocessor via PIA U7. Every time a write to the speech chip is performed, the speech chip responds with an acknowledgement. The microprocessor attempts to send 9 bytes of initialization data to the speech chip one at a time, waiting for the acknowledgement for each byte. If it is successful in doing this, the speech chip is deemed functional and the microprocessor flashes the LED. The microprocessor now initializes the 2 PIAs and waits for an interrupt. Okay. SQUAWK and TALK accepts address signals from the MPU to select one of the sounds or speech signals stored in its memory. It then plays the request by controlling the sound generator chip or the digital analog converter for sounds or the speech generator chip for speech. The SQUAWK and TALK is notified of a sound speech request by an interrupt from the MPU. This interrupt is generated by toggling the solenoid bank select signal of the MPU on the MPU, which is the sound interrupt input to the SQUAWK and TALK. The code number of the sound speech required is passed as 2 half bytes, which are called nibbles, cutely, over the MPU solenoid select lines, which are the sound select inputs to the SQUAWK and TALK. The current timing for this process is shown below. You see what I'm saying? Bally did us right. I mean, they're showing, they don't need to show all this. It's kind of like, if you look at some of the old data sheets for the old processors, they showed stuff like this too, so I guess at the time it was fairly common. And then they tell you how the speech and sound circuits work. So basically, we may need that whenever we figure out what's wrong. But we've got 5 flashes that we're supposed to get, and we're getting 4. But I'm thinking that the first one is actually the flicker, which means we're getting 3 flashes. So we're getting the 2 PIAs work, and then whenever it gets up to U6, I don't think that's working. No, U12. I don't think that's working. So we need to look at U12 and U8. It seems like neither one of those are working. If they're in a socket, it could just be that the legs are dirty and they need clean. So let's go find U12. Well, guess what? U12 does not have a chip in it. However, after looking, it's not supposed to. So a few of the games, they didn't use that. It's a sound generator. And on this game, they didn't use it. So on this one, we're not looking for 5 flashes. We're only looking for 4 flashes, which causes me problems because now I don't know if we've got the flicker and 3 flashes or 4 flashes. Okay, so the next flicker is obtained by U8. So it could just be that this U8 is dirty. How does it look? It don't look great, does it? So let me pry it out and we'll try cleaning it and putting it back in. Now what could be happening too is that the board is booting, but I can't hear it because of some other problem. It could be the speaker's unplugged. Remember we had to replace that in an earlier video if you didn't see that. It could be that some of these capacitors are bad, so there's other things that it could be. But let me pull that chip out and see if we can get our final flash. All right, well that will do it. It's a TMS 5200 and one of the legs is broken off either because it just was or I just did it. Okay, and they are pretty filthy. Okay, so I'm going to clean those carefully, and then if I don't think I've got another one of these. If I don't, I'm going to try to solder a leg back on. There where it's missing, but if a lot of these legs are really weak, we're probably not going to be able to save it. I could put I may put a socket on it, or I could put you can put the machine pin sockets on it and then just put a little solder in it to basically create a new leg, and then it sticks up a little bit because it's in the socket and you install that in a socket. So we may try that. But let me see how clean I can get these without destroying any more of them. Alright, so looking around the line, it looks like it's about a $25 chip. But all the other legs were pretty strong, so whenever I cleaned them off, they cleaned up pretty good and didn't seem weak, but that one definitely is. So what I did was I cut a leg off another chip and then carefully soldered it in. What I usually do is I solder it inside the old leg. It just seems to fit in the socket better if you do that. Now it would be better if it wasn't quite that thick there where the glob of solder is. If I could get that thinner, it'd be better because that won't really fit in the socket that well. But what I'm going to do is I'm going to take I'm going to see if I've got a new socket. And I'll just put this inside a new socket and then put the new socket inside the other one. So that if that leg being thicker messes up the socket, it'll just mess up the socket that I'm piggybacking on it. But it's soldered on there pretty good. And so it lines up pretty good if you do it on the inside. If you try to solder it to the outside, usually that doesn't work that great. So that's how I usually do it. Alright, so I got these nice double wipe sockets here that are a little wide, you know, so that there's plenty of room for the leg to go down in there. So put that in one of those. Now it's probably bent that particular part of the socket out a little bit, but that's all good. So now that I've got it like that, I got nice, beautiful legs to put in the socket that's permanently on the board. And worst case scenario, you could just swap the socket on the board too if you ended up screwing it up with that fatty leg there. Alright folks, when I put it back in, I get the same exact thing. So what I did was I took the chip out, and you can see that the flash code is the same. That's the flicker. 1, 2, 3. We're getting 3 flashes. This game doesn't have a fourth this game doesn't check this, so it only has 4 flashes total. So this chip is not installed. There's some jumpers down here to get rid of it. The code is slightly different because of that. Fathom is the same. There's a couple other games that don't use that chip. So the 4th flash just checks this, and it's not installed because I've got it removed. So whether it's installed or not, I get the same thing. So I'm thinking though, see how this socket is different? It's not a dual wipe, it's the AGAT. Those aren't really, I think those are the ones that people don't like. And look how the pin is still stuck. The broke off leg is still stuck in that top piece of the socket. So I'm thinking it could just be as simple as that socket needs replaced with one that is like I was showing, and it's a dual wipe. So what I'm going to do is I'm going to check continuity between each leg and then the pin under this socket to make sure that the top of the leg as it enters the chip is connected to the bottom of the socket, right? And then if that's fine, then I'm going to remove that socket and solder this one into place, or one like it into place, where we do the piggyback thing. It's just those sockets with the closed off connection where you can't hardly get to the pin. I don't know if that's grabbing it from both sides of the pin or just one side. So if that pin is in there just a little bit crooked or it's a little thin because it's a new socket, it may not be making contact. That's where we're at. All right, folks, so no matter what I do, I could not get that chip to work. However, I looked around in the back and I happen to have another one of the chips. Now, I don't know where I would have ever got that, but I've gotten an extensive collection of stuff. It's also on Gauntlet, the arcade game, so maybe I got it off of one of them at some point or something. I don't know. So the warrior needs food. It's the same chip, I believe. If I'm wrong, I will be instantly corrected, so don't worry about it. So I put it in, and it looks like we get the right flash code. Look, that's the blink. 1, 2, 3, 4. There's our fourth one we weren't getting before. But still no sound. You know it should play some kind of startup sound. Nothing. Nothing, people. Nothing at all. And if I press this test button, I don't hear anything. I'm not sure that the test button always produces sound, but okay, so that's where we're at. I've messed with these volume knobs too. I get nothing. Now this is our amp. Usually, if the amp is working, you can kind of play with some of the resistors and stuff, and you'll start hearing some humming just from the electricity coming out of my hands, you know. But nothing. So we need to check to make sure our speaker's hooked up. I've looked, it's physically hooked up, but is it connected right? And we need to check voltages on the board and look at the schematics, see how the amplifier works and all that kind of stuff. Okay, so we are looking at the schematics. The first thing that I'm looking at is connector J2 is where the speaker plugs in. So it's pin 1 and pin 2 go off to the speaker. So the first thing I'm going to do is check, I'm going to unplug that and I'm going to check the resistance across the speaker leads, which will tell me if the speaker's plugged into the other end. Now it is plugged in, I can see it, but the speaker might be messed up. Now, if you watch the earlier videos, we put a brand new speaker in it, but we still could have a problem with the wiring or something. So I'm going to check all the way from here by unplugging this connector and just check the resistance across the two, and it should be around 4 ohms or somewhere near that. That's impedance. Everybody always corrects me. Oh, you don't know what he's talking about. Okay, yeah, I know it's impedance, but it's still, there's going to be about 4 ohms resistance too. That's just how it works. So we're going to check it, and if I've got like 2 megs resistance, well, something ain't connected or something's wrong, or the speaker coil, the voice coil's blown or something like that. Okay, so it's just an easy way to tell if all of your wiring's all right. So we're going to check that first, and then we'll move backwards through it. So a lot of times when we're working on stuff, we say, where do you start? You start at the wall. Well, on this one, we're kind of moving backwards. So I'm going to check this first because we know the speaker was messed up, and it would be easy for a wire to be unplugged or something, or a connector to be wrong or something, right? So we're going to check that first, and then after that, we're going to check voltages and make sure we've got all of our proper voltages. All right, do you hear that? So the measurement was never 4 because it actually runs through the potentiometer up on the front. So the lowest I could get it by turning it all the way up was like 15 ohms, but that's still right, you know. It's just running. They've got one of the speaker lines running through the potentiometer. But that's probably why we couldn't hear. I can hear a hum now. See? Just my hand is introducing noise into it. Okay, so yeah. So let's measure some voltages. They're probably there, or the thing wouldn't be amplifying, but we'll measure the voltages to make sure they're all right. Okay, so the next thing I've tested is the voltages. So test point 1 on the board is the ground. Test point 2 is 5 volts. It's correct. It's at 5.1 volt actually. Test point 3 is 11.5. It's around that way. It's not regulated though, so if you're anywhere near that, that's fine. Okay, and it's right. And then you have this interesting one down here, where they create a -5 on the board, and our -5 is there as well. So all of our voltages are there, and the board is booting up and doing its flash code, and everything's cool. And we're getting the hum and all of that, right? Another interesting thing is, remember I said that if it doesn't use the AY3-8912 sound chip, that you have these little jumpers that are installed. Well, it's these right here, the EE jumpers. So basically the game board is selecting sounds from here, sound select signals coming in from the MPU, and then when it comes in, it originally routed through this sound chip, but since that's not there, that would create a problem. So you put these little jumpers in, and it routes the sound select around the sound chip. It goes up to the PIA 6821, right? That's kind of neat. Okay, so anyway, let's look at the output stage. Again, we have no sound, but we have a buzzing. So just trying to logically track it down. Here's where our speaker was. It's now buzzing. So does that C27, is it at least passing sound through? Well, it must be, or we wouldn't get a buzzing, right? And then here is the amplifier, just a cheap little TDA 2002. It's getting its input here on pin 1. Okay? So it could be that with no input, that thing is just buzzing whenever you turn up the volume, that you're getting, it's amplifying nothing basically. But we kind of know that from here over is at least halfway working because you're getting a hum. But that's kind of all that means. We know the voltages are right, and we know that this is kind of working, right? But apparently it's not getting anything to amplify. So if you look, there are two parts of a LM3900, which they are notorious for going bad, right? But some of the sound comes through this side, and some of the sound comes through this side. And they don't explicitly tell you what does what, although it may in that book we were reading earlier. But if you look real close, right here there is they show you where the volume control voltage is to control the speech. Well, that tells you that the speech must be coming through that part. Okay, so there is a little cap that it goes through. Now these back boxes get hot, so these caps cook. If that cap is screwed up, that C25, none of your speech would make its way through. Okay. And then you also have here, it says TMS 5200, that's part of the speech, comes back, runs through this side, which is another LM3900, a U13. And look at all of the capacitors that it runs through. C19, an electrolytic. C24, another electrolytic. C23 appears to be an electrolytic. Oh, wait a minute. No, they're not. They're not electrolytics, but C24 is. C28 is involved. C25. So if any of several of those go bad, the signal from the speech chip would never make its way through. Okay. But then you also have this line coming from this other side here. Now this one says sound volume control voltage. So this is like more of the sounds. Okay. Instead of the speech. But it's the same thing. There's another cap there. It could just be that cap's bad and that cap's bad, and so none of the sound is making its way through. Or it could be that U14, this LM3900 chip, is bad. So it's kind of like a preamp, and then it's not allowing the sound to pass through. So it could be something like that. Many more electrolytics. I've messed with these before and other Bally soundboards of this vintage, and the caps are usually a problem. So even if they are working, they'll buzz and hum and just cause all kinds of issues. So what I'm going to do is I'm going to pull the board out and I'm going to change a whole ton of those caps. And then we'll put it back in and then just see if that got it. And if that didn't, I'm going to try changing this preamp too, the 3900. at U14. If that doesn't get it, I'm going to try changing the other preamp at U13. Just while we're looking at this too, if you look, this chip here that's been taken out that we were talking about, the outputs are the A, B, C there, and they come down. There's a test point for the output of it. Okay. And go into U13 at that area. So this this area here, well, I guess that's needed. Yeah, that's where the sound volume is coming from. This area here, though, isn't necessarily needed. And then here is the DAC signal coming out of the AD. Here it is. AD558. And it comes down and joins after this area. But it also has a capacitor. So if any of those capacitors aren't working right, that all of that sound, that part of the sound, is just completely gone. Okay, so but we're fortunate that, like, if the DAC is bad, the digital analog converter, we would still get the speech stuff, and if the speech thing is bad, then we'd still get the digital analog converter sounds. So we should start getting some of it back if we replace capacitors. Okay, so in the past, I've figured out that it's the smaller capacitors usually that are making the sound disappear. But we'll see. But there are caps everywhere. Some of them only used for power, others used for sound. If you've got a cap in the power section, though, that can give you a lot of static and distortion. So I'm going to change some of these, and we'll see what's what. You also have to worry about these pots, these volume pots. They can get messed up to where they won't allow sound through it either. So, same thing. Okay, so I'm going to start swapping some caps. All right, new caps. I didn't have the axial ones. Deal with it, people. And I replaced that U14, the last stage of the preamp, just because I hate those things. They're always screwed up on Space Invaders and what is the other game that I'm always replacing those? Asteroids. Very common. Okay, so let's see if we get anything different. It sounds different. Did you hear the little boop?
Time your shot, light gorgons.
There's no background sounds, but the speech is obviously there. Boy, he's got a low voice, doesn't he? I think that's computer manipulated. I don't believe that anyone can say, time your shots, right gorgons. Well, I messed that up.
Time your shots,
Right gorgons. I think that's what he's saying. Whoop. I should have timed my shot like he said. There's no background sounds. Interesting.
Time your shot, light gorgons.
Okay, usually if you hit the test on a Bally soundboard, it will play like everything that it can play, basically.
Match for extra ball. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Conquered. Olympus. Conquered. Extended play qualified. Olympus reward doubled. Lighting torches doubles Olympus reward. Medusa's revenge. Enter Neptune's cove. Collect Neptune's treasure. Time your shot. Light gorgons. Right gorgons. Prepare for battle. Conquer Olympus. Challenge Medusa.
Looks like it reset because it did that, but it never played any sounds. It's just speech. So the speech side is working, but the sound side is not. All of the sound is created by the analog to digital converter, or it runs through that. So interesting. Okay, so we need to look at the schematics some more. And giddy up, ba-boom. So we're back to the schematics. So this over here is to hook up an external vocalizer board, which I don't think they ever utilize. It's just a port that can go out with a ribbon cable, so none of that is used. You have a MPU here, 6802. You have ROMs, U2, 3, 4, and 5. You have a RAM, which is a 6810. Okay, and address decoder. You got an address decoder chip. Okay, so the MPU can do its thing, but it needs something to tell it when to do it. So the board connects through here, and the sound select signals come up to this PIA, Peripheral Interface Adapter, 6821. Okay, now there's also up here another one, and there is a reset area. Okay, so the MPU gets signals from the MPU chip gets signals from the main MPU of the game board telling it what to do. And so these come in and talk to it, and it uses the information stored in the ROMs, et cetera, and it can instruct this PIA to make the speech happen. So the speech comes out, comes through here, it goes through a low-pass filter, which would explain the giddy up, ba-boom stuff, you know. That is so low, I guess. And then it goes through this amplifier, a preamp, blah, blah, blah. This is the one that we already replaced, okay? So there is our speech. It's coming in right through here. Now it has the volume, a voltage controlling the volume that comes from U13, okay? Now there is another one down here that we looked at for just a second. So since we don't have this sound synthesizer chip, we don't have this input. So this part doesn't do anything. There's no input to it. However, this part, which is also U13, all these are U13, controls the volume to the sounds. Okay? All of the sounds, every single sound comes out of the DAC, the AD558. That doesn't come from speech, because this part only comes from this sound chip that is not installed on this game. Okay, so that's the area that we need to look at. We've got something going on here maybe, but we already replaced U14. Okay, we replaced the couple capacitors there, so it could be this line that controls the volume. So it could be working, but the board is just telling it to be dead, right? Or it could be the DAC, which is in a socket. It could be the socket for the digital analog converter. But if you look before that, it's getting its signal just from data lines. It's basically reading things out of the ROM chips, and I guess it's some kind of little wave file or something that is making analog. Okay, so our problem kind of has to be either U13 or this DAC chip or the socket that it's in. So that's where I'm going to aim my, that's where I'm going to look. If there was a problem with the ROMs themselves, you'd think that it would fail like the boot up test, but maybe not. But that's next. We're going to replace that socket for the DAC, and then we're going to replace U13. And the reason I'm replacing this is because those LM3900s are very problematic. They're known to go bad. Now it's working up here because it's the low pass filter and the voice sounds great. But it could be that one's working, and maybe that one's working, but there's no input. But maybe one of these two is screwed up. I guess that one can't be screwed up because it's the volume control for the speech. But it could be this one's got problems. So as a preventative thing, since they do fail a lot, that particular chip, I'm going to replace it. They're very cheap. It's like a 30-cent chip, and but I don't have another DAC. But we're going to check out the socket. After looking closer, if you look, this digital analog converter, all of this info comes right through C43 And I forgot to change C43. So I'm going to change that first, and then we'll check to see if just that one cap was the problem. I didn't change it because I didn't have an axial cap, and it fits in there kind of weird. But I have now. Yep. So I guess it was one cap. Okay. Let's see, though, if everything's there.
Yellow shot. Right there.
Whoop. Did it not sense it? Come on now. I guess it would help if I knew how to play it.
Match 4 for extra ball.
Oh no, it kind of sounds like it's not making many sounds. Yeah, some of them aren't doing anything. Might be a dip switch thing or something. But some of them don't sound like they're doing anything. It almost sounds like some of the, I don't know if that's all it does. I'm gonna have to watch somebody else's video. Alright, so we're in the manual. Sound option. The game is designed to make several tones and noises to announce power up, game up, etc. The tones are intended to attract attention to the game and increase game usage. The tones are controlled by pressing self-test button until the number 18 shows on the match ball in play display. Now pulse the replay button to the desired sound setting. Okay, so if you got on setting 0 or 1, most switches associated chimes without feature background. Okay, so that's probably what it's set on, something like that. Setting 2, most scoring will have a noise effect with the background. Setting 3, most all scoring will have a noise effect with the background. And it says, note, to correct clarities of speech and sound, adjust the controls as follows. Turn the remote volume control on the front door all the way up. Turn the speech volume control on the printed circuit board fully clockwise, then counterclockwise until speech is clear and understandable. Turn the sound volume control fully clockwise, then turn counterclockwise until the sound is not garbled. Then adjust the remote volume control back down to the desired volume level. Okay, so we need to go in, see if setting 18, see what it's set on, and change it to 3, because we want all of the noise we can get. That's how I live life, people. If you're not living like that, you're boring. Come on now, we got to turn everything on. Hey, we're going to jack it up in here. About to get loud in the pinball store tonight. All right, so 18 was set on 0, which means some scoring has a chime sound. Not even everything has a sound. Looks like 1 would be something similar. Maybe a few more things that you score would have a chime sound. 2 is most things some things have a sound and there is a background sound. And then 3 is there's a background sound and pretty much everything has an associated sound. So let's go back out into the main game. We still had that weird thing where the ball ended. Okay, let's see if it sounds different.
I'm your shop. Light organs.
That's what I was looking for. Very cool. Well, that one dip. Okay. Yeah, I can't tell when it loses the ball, apparently. So there's some issues going on, but I think we've got the soundboard fixed. Wouldn't you agree? What a beautiful playfield. Okay, if you didn't see the beginning of the video, we still have work to do to the playfield, but we're also going to replace that soundboard with a brand new one. A brand new soundboard. Okay. There is a brand new one that has been made by a gentleman that allows you to put more music and things like that in it, and we're going to do a whole other video on his great invention. This thing still has some issues. I cleaned the switches, so I think this is working better now. These reset, but sometimes they don't immediately drop because they get caught on the bar. So we still got that. There's also a weird light right here. I'm not sure what the deal is with that, but the thing, it doesn't come on at the right time. It doesn't seem like, but it could just be a code thing. And then the two on the end down there just blink, not really in succession. So that's a little weird too. These don't make a noise when you go through them, so I'm not positive I'm hitting them. I think I am. They're test fine in the test. The rubbers down here aren't quite the right size. The ball gets stuck sometimes. That might, sometimes the ball lands in an out hole and it doesn't move to the next ball. So there's still a few little things, but we'll play it just a little bit so we can hear the beautiful music. Oh, there's a light bulb right there behind the drop targets too. Missed it. And I forgot my save. We should be louder. There we go. I missed it. Enter Olympus. Whoa! We knocked the light shield off. See, like, I'm not sure if the lights are working right up there. Need to enter Olympus. Oh, I didn't time it. I forgot. I missed it again. Enter Olympus. Oh, that's Neptune. That's not Olympus. Enter Olympus. Where is Olympus? need to find Olympus. Ooh, kissed it. Kissed it again. Trying. Bounce over in there. I don't know how you do that from the top playfield. I'm not so sure you can do that from the top. The kicker could do it. Like that might do it, maybe.
Challenge Medusa.
All right, so that's how far we are so far. Leave your comments below. Hope you enjoyed it. Hope that helps you fix your squawk and talk, but keep in mind we had to replace about everything. Give us a thumbs up for taking the trouble to film it for you, and thank you to everybody that's been using our Amazon links. If you don't know about that, there is a link down below, and there is a link on our website. Go to lionsarcade.com. We have a parts page. Bunch of links to stuff that we use in our videos, cleaning products and tools and stuff like that. We've got some of our t-shirts on there and things. If you follow some of those links, they take you to Amazon, or you can just use the link below to Amazon. So the whole purpose of that is, if you use our link to go to Amazon and then buy something on Amazon, it gives us a tip for sending you there. So we appreciate everybody that's been doing that. The number has been going up, up, up. Thank you, folks. We appreciate it. I don't have enough to buy a vet yet, but I'm working that way. So if you're going to buy anything on Amazon, click our link to take you there, and it gives us a little tip. Thank you for that. And last but not least, don't forget to watch my brother Donnie. My brother Donnie has his own channel here on YouTube. A fun time is had by all. I'm over there with him a lot of the times. Lately, we've been finishing up, repairing our little building that we bought. Got it rented and all of that. Got videos of all of that on there, and we have moved on to, we've done some vehicle repairs, and then we're doing another mobile home that we're renovating. We're renovating a mobile home. Now, you know you want to see that, so go check that out if you haven't already. But we're going to do at least one more video. We're just going to do tons of videos on this. We might just do 100 videos on this Medusa, right, until we get it perfect. The look at this. They have a little, there's a little clip broke on it. So maybe if I put this one here, which gets all of the vibration, maybe it would be better to have a nice perfect one on there. And maybe we put this one up here, and maybe since it doesn't get hit as much, it won't be as bad. We'll see. But we'll do other videos, but we need to do at least one more so we can show off this gentleman's soundboard that he's invented. Okay, so we'll see you on the next video, which will probably be tomorrow, where we do the new soundboard. So see you then. Hope you enjoyed it so far. Leave your comments below, and we'll see you next time.